And it's time for your favorite word problems. So I took this from your textbook. Just so you know, a lot of people don't read the paragraph right before the first explain, but it gives us some really interesting and awesome equations to use. So if you tried to look for what log equation do I use, it's in that paragraph. So I copied and pasted it right here front and center so you can see it. So let's read the problem and let's try and fill it out. Alright, so it says, during a concert where there's music playing, an orchestra plays a piece of music in which its volume increases from one measure to the next, thus tripling its sound intensity. That's a lot. Find the number of decibels the loudness of the sound increases between the two measures. So let's first of all, let's identify some variables. So since they will use the word intensity, I'm going to say let's let I, for intensity, be the intensity of the first measure. And since it's tripling, what number do you think I'm going to put next to I as I'm multiplying? 2, 3, 4? 3. Alright, let's go ahead and write an expression. So the increase in loudness, it's going to go from I intensity to 3I. That's a lot. Alright, now if you're wondering, well, where is the equation? It's right here, guys. Don't freak out. It's alright. We're going to be okay. So here for I, I'm going to put 3I in for that first one, and I for that second one. Alright, first things first, it says substitute, which we did, write an expression, which we did, distributive. You notice how they both have a what in common? A 10. Let's take that 10 and let's put it out. Get out of here, 10. Go over there. Next thing we're going to do is, let's go ahead and separate out the 3 from the I divided by I initial. So 3, you get your own little box. You don't have to share. That's nice. The next thing we're going to do is we're going to simplify. Now I know this looks complicated. I know this. I get it, guys. But if I asked you what 4 take away 4 is, what would you say? 0. If I said x take away x, what would you say? 0 again. What if I said log base 10 of 4 take away log base 10 of 4? Again, 0. Anything take away itself is essentially going to be 0, guys. So that's going to be log 3 plus 0. And just like if I said 0 plus 2, what would you say? 2, right? 0 plus x, what would you say it is? X. So if I said log 3 plus 0, what would you say? Log 3. So I'm going to write that in. And we're going to simplify this out. Now we do have a decimals calculator. Let's use it. And let's figure out how many decibel of loudness this concert is going to rock the house with. So I have my Decimals Scientific Calculator. That's 10. Function, there you are, log. Base, or not base 3, but times 3. And what would that be? That'd be about 4.77. Now let's round it. 4.77. So we're going to start from here and write that in as approximately 4.77. So the loudness of the sound increases about 4.77 decibels. We're almost home free, guys, because letter B is next. It says the population of the United States in 2012 was 313.9 million. If the population increases exponentially at an average rate of about 1%, just 1% each year, how long will it take the population to double? That's a lot. Alright, so the initial population, just again, I copied and pasted this from your textbook, so keep that in mind for population problems. So here there's our initial population that they gave us for P, initial, and our rate. So here that would be 2 times 3.19, 313.9. So let's actually figure out that out. You know, go ahead and calculate that on your calculator. So that would be about 627.8. All right, now what are we going to do with all these values, right? That's your next question. Well, we're going to plug some stuff in. So we're going to write our exponential model. It's listed here. Now I want to get t by itself so I can figure out what point it's going to double, right? Because it's asking how long, so I want to solve for t because that's time. Alright, so first things first, I have a p initial that I need to get rid of. What's the opposite of multiplying? Divide, and that's essentially what they do to both sides. It cancels out and we're left with this. Next thing we're going to do is we're going to write our log. Since here we write, we took our both log bases. We're going to write this as log base 1 plus r. So whatever we do to one side, you got to do the same thing on the other. Alright. After that, we're going to write the definition of a log. Okay. So that would be, remember whenever we have something where it's log base 10 times 10, or log base x times x, or in this case, log base 1 plus r times 1 plus r, they're all going to cancel out to be 1. Alright, so that way t is left over. And I'm left with log base 1 plus r times p over po. Okay. We are going to change the base property, so we're going to do that right now. So that would be log base p po. So notice how what's in parentheses is going to go on top. And what's our base value is going to go on the bottom. Okay, so you're like, well, now what do I do with this? Well, we're going to use it to figure out how much it's going to take to double. Alright, so let's go ahead and put in our values, 6 to 7.8, and our rate, which was about 1%, which I don't think we changed to a decimal, did we? If you haven't already, do that now. And that would be about 0.01. Okay. Whether you're using a basic calculator or decimal graphing calculator, go ahead and divide that out and figure out what this would be. And you don't really need a calculator for this one, but go ahead and try this out. 1 plus 0.01. And let's go ahead and write that there. Take some time, work it out. That'd be 101 and 2. Alright, let's go ahead and figure out what log base 2 and log 2 and log 1.01 are. At this point, yes, I will show you the decimals calculator so we can calculate what those decimal values are. Alright, so decimals calculator, that's log 2, which is done there, and log 1.01. Notice how I'm pressing enter just to keep those values up and viewable. And then since we kind of will be dividing those numbers anyways, let's go ahead and figure out right now what 0.301 is divided by 0.004. Now I'm not going to write the whole decimal, just a little bit of it. But it looks like we get the number 75, which translates to how much time it's going to take for that population to double. And remember, they're measuring 75.25. That's in years. That's a long time. Well, depending. But let's go ahead and record these values here on our piece of paper. So that would be, oops, sorry about that. Did not mean to go that far. 0.301 and 0.004, And we got that to be about 75.25, which is actually about 75.25 years for that population to double. Just like it says at the bottom of your packet and now on my screen, stop and do the problems in your packet. We will come back to go over the homework and some of the checkpoint problems, okay? See you in a little bit.